Newton presented three laws that govern the nature of motion. These laws are derived from Galileo's ideas and experiments. Let's take a look at Galileo's experiments with inclined planes. Consider a marble resting on a plane inclined on both sides. Now, the marble is released from the left, that is, end A. The marble rolls down the slope and travels up the other slope till it reaches the same height from which it was released. In this case, the inclinations of the planes on both sides were equal. Therefore, the distance covered by the marble rolling down was the same as the distance it climbed up on the other plane. Let's see what happens if the angle of inclination of the right-hand side of the plane is gradually decreased. The marble travels a longer distance till it reaches its original height. The angle of inclination of the right-hand side of the plane has been reduced to 0. The plane is horizontal. How far will the marble travel now? It travels quite a distance. The marble stops eventually because of the frictional force opposing its motion. In practical situations, it is difficult to achieve zero unbalanced force because of frictional force. However, friction can be minimized by using a smooth marble on a smooth surface and using lubricants. If the surface of the plane was completely frictionless, the marble would travel forever, trying to reach its original height. Thus, a marble in motion would keep moving if unbalanced forces or the net force on the marble was 0. From this, Galileo deduced that an unbalanced external force is required to change the motion of an object. But once the object starts moving, the application of no net force is required to keep it in uniform motion. Consider the example of spacecraft Pioneer 1, launched about 20 years ago. Deep in space, it keeps moving even without the aid of engines, because there is no frictional force in space to stop it. The tendency of undisturbed objects to stay at rest or to keep moving with the same velocity is called inertia. Newton's first law of motion states that an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. That's why the first law of motion is also known as the law of inertia.